Hi, so in this video we are going to discuss about waveforms. What are waveforms? Any signal plotted with respect to time can be called as a waveform. This is an interactive guide I'm taking as it is from this website pudding.cool, and I'm just presenting it. So let's start. You can go to this website and do it on your own, but I'm just guiding you through some important principles which we can learn from this tutorial. Okay, so this is okay. What is a waveform? Waveform is basically any signal which is changing with respect to time. Let's say I'm here. Let's say a signal like the temperature of the day as the day it's morning time, some temperature. As the day progresses, the temperature increases because of sun, and then gradually in the evening it reduces, and in the night it comes further down, and then next day again it increases. So this temperature reading could be one kind of waveform where the y-axis will be the temperature and the x-axis will be the time. um, but in this tutorial, we are looking at audio waveforms. Audio waveforms are the y-axis is the audio signal, and the means the uh, uh, x-axis is the time, and y-axis is the audio waveform. I will show in the video how it goes. Okay, so if I can also play this sound, so you can hear slight buzz. This is a this is how I can play the sound. Okay, now let's start with the first concept in this tutorial, which is how do we read a waveform. Okay, so to read a waveform, first is the y-axis is the displacement and x-axis is the time. Displacement with respect to time. Okay, what displacement I will discuss, I will tell. So let's first look at the x-axis. In the x-axis we have time. Let's say time is 0 to 1 seconds, and this waveform has got one wave in 1 second, so one cycle per second, and it's a periodic waveform, so the same cycle repeats over and over. So you can see on the x-axis time 0 seconds to 1 seconds is there. Now let's look at the y-axis. The y-axis is the displacement. Displacement of what? Let's say if it is a string, you pluck a string is going back and forth. Those oscillations could be the displacement from the mean position. That could be your displacement. Or when I'm speaking into a microphone has got a membrane which vibrates, right? And that position of the center point of that membrane could be my reference, and as it deviates from its mean position, that displacement could be plotted on the y-axis. So this waveform in that case will be the position of the center point of the membrane with respect to time. Okay. Now let's look at the concept of amplitude. What is amplitude? Amplitude is basically the height on the y-axis. What is the effect of amplitude? If I change my amplitude, if I reduce the amplitude, what happens? The volume goes down, and if I increase the amplitude, volume increases, right? If my membrane is vibrating to a larger displacement, then I hear more sound. But if it is very minor vibration, the amplitude, or the maximum displacement is very small, then it will be very faint sound, right? So amplitude is related to the volume. So summary, a waveform is a graph that shows a wave's change in displacement over time. The waveform's amplitude, the height, controls the wave's maximum displacement, which you hear as the volume. Now the next concept of frequency. So what is this concept of frequency? So frequency means periodicity. So how many cycles are there in 1 second of the waveform. So in 1 second, how many cycles are there? That is basically frequency. The units of frequency are hertz. And so frequency is the concept of pitch. Pitch is when you hear a sound, you will hear a pitch. Let's say, I'll give a very nice example to remember this. When you hear music, you hear different notes, sa re ga. So how are they different? They're different in their pitch or fundamental frequency. So for example, I say sa re ga. So ga has got a higher frequency, sa has got a lower frequency as compared to ga. Okay, so this is the concept of frequency. Now, yes, we can change the frequency. See, if I increase the frequency to 3, I don't know why this is moving. Can I stop it somehow? Okay, so basically this is moving very fast. If this is, let's say, half a waveform in 1 second, so this is 1 second window, but if I increase it to 1 cycle per second, I could make it 2 cycles per second, and I can make it 3 cycles per second. You can also hear how the audio quality is changing. So higher frequency sound is different from lower frequency sound. You can hear it. Okay, so the waveform is just a schematic. Okay, yeah, so we can adjust the frequency to make it a higher pitch or a lower pitch. Now, the next concept, how sound works. Okay, I will skip this part. This is not important, that how air is vibrating. We may not agree with that interpretation. Okay, let's come to this concept, which is the concept of harmonics. So far we have been seeing at sinusoidal waveforms, but the waveform need not be only sinusoids. It could also have multiples, other frequencies, not only a single frequency, but multiple frequencies could be present. Okay, so this is the concept of sinusoids. You can change the amplitude, you can change the frequency. Now see what happens in the this spectrum. This is a spectrum. Basically, spectrum is a kind of Fourier transform. It tells you what is the amplitude or what is the energy in each frequency. So this is a frequency of 1 Hertz. So you can see at 1 Hertz you have amplitude of 1, and if you go to higher frequencies, it's all 0. Means those frequencies are absent basically. But if I change the frequency to, let's say, 1.5, now you can see at 1.5 this peak is there. So from here you can see how what is the effect of changing frequency on the spectrum, what is the effect of changing amplitude. I decrease the amplitude and correspondingly you can see the amplitude going down there. So this is the spectrum. So how the spectrum looks like. Okay, now let's go on to the next concept. Yes, now let's take a signal which is not sinusoid. In this case it's a triangular waveform, and now you can hear the difference. You can hear that it has got a fuller or brighter sound, right? Now if you look at the spectrum, what you find is, yes, it has got one fundamental frequency of 1 Hertz, but there are also other frequencies present. So if I break down this signal into sinusoids, I will get something like this. I get this signal plus this signal of 3 Hertz plus some signal of 5 Hertz with a lower amplitude, of course. Okay, so what happens is, so this is a periodic signal with the same period of 1 Hertz, but there are harmonics or higher multiples of that harmonic, of that fundamental frequency present. So this is 1 Hertz, then 2 Hertz, 3 Hertz, 4 Hertz, 5 Hertz. All these are harmonics, basically the integer multiple. So if I change it, if I make it 1.5, you can see the harmonics also have shifted to 1.5, 3, 4.5, 6, 7.5, like that. And you can hear also sound has changed, right? Okay, I'll reduce the volume. This is another kind of a waveform, square waveform. Um, a square waveform, the spectrum looks like this. Now what you see is Sawtooth waveform. The spectrum looks like this. Now what you see here is, earlier we didn't have 2 hertz, 4 hertz, the even harmonics, even multiples of the root was not there. But now we have even multiples also present. This is because this is a non-symmetric waveform. We will look at the mathematical details in subsequent lectures, but this video is just for you to appreciate the concept intuitively, that what is the need of sinusoidal analysis, what is the need of amplitude, frequency, and all these concepts. Very intuitively you can understand. Okay, let's come to the next topic, which is additive synthesis. It means when you add different waveforms, how does the spectrum change? So every signal, every periodic signal can be considered as consisting of these elementary sinusoidal signals, right? Okay, let's look at this. So this is a signal. So these are two signals. This one is, the blue one is 1 hertz, and this one is, you can see 3 cycles per second. This is a 1 second window, 3 cycles per second. So this has got 3 hertz frequency. Now, if we add these two signals linearly, what will happen? So what you get is, this is convergence, okay. So when I add the two, it looks like a square wave. Not a very good square wave, but yes, a square wave. Now what will happen if I add more harmonics? Okay. So okay, you can see the original square wave had this kind of spectrum. So 1, 0.33, and this one is 0.2. And if I add these sinusoids, one sinusoid of 1 hertz frequency, 3 hertz frequency, 5 hertz frequency, if I add them up all, what will happen? So we will get a sinusoid. You can see number of harmonics if I increase. You can see that when I increase the harmonics, I get a more higher pitch sound, because the number of, as I increase the number of harmonics, then the higher frequencies are increasing. You can hear the quality. See, very thin sound. You can see, okay. And if I add them up all, it looks like this. If I change it, it becomes closer and closer to a square wave. Okay, this is the thing. Next concept is phase. So what is phase? Phase is basically the shift from the origin. So when we have sinusoid of 2 pi ft plus phi, that phi is the phase term, and I can change the phase. So see, this is 0, and this is, okay, let's say this is almost 90 degrees, somewhere here, 90 degrees. So this, the red curve is 90 degrees shifted. So one cycle is 360 degrees or 2 pi, but 1/4 of a cycle is 90 degrees, half of the cycle is 180 degrees. Let me see, yeah. So it's half cycle shift. And if I shift the cycle by 3/4, or I can shift it by 360, which means I shift it by 1 complete cycle. And convergence. So what happens if I add? See, if I add 0 degrees phase, what will happen? They will reinforce each other. The signal will become stronger. But if I add 180 degrees, almost 180 degrees phase, what will happen? They will cancel out each other, right? That is the importance of phase. Okay, now chords. What are chords? If you add uh, two signals which are not multiples of each other, the sound quality will be very different. That is the concept of chord. So you can see these three are not multiples of each other in frequency. That's it. So this is more or less the concept of waveforms as we saw in this video, and I would request you to go through this whole tutorial on your own on this website, and you will have much more insights. Thank you very much.